For this final lesson in Chapter 14, we are going to be solving trigonometric equations. Something that you need to remember is that solving these equations are just like solving any other equations in that you are undoing whatever the process is to isolate an unknown quantity, and you'll be using order of operations as always. This is different than verifying, which is what we did the last time, because with verifying you had to simplify each side of the equation to prove that the equation was true. These equations are true, we're just isolating a variable. If you look in your textbook, you'll see that there's a way to solve for a primary solution and a general solution. We are only going to be looking at primary solutions, which means anything from 0 to 2 pi or anything from 0 to 360 degrees. If they ask you to solve for a variable, x, y, s, r, something along those lines, you're going to put your calculator in radians. If they give you theta that you are going to be solving for, you need to be in degrees. So let's take a look at the first problem. We are going to solve for theta, which means that if I'm putting anything into my calculator, it will need to be in degree mode. I need to get theta all on one side of the equation, so I will divide by the cosine of theta on both sides. And I know that sine over cosine is equal to tangent. So tangent of theta is equal to 3. The first thing I'll do is I'll look on my unit circle to see if I can find any tangent equal to 3. In this case I can't, so I will put this into my calculator. Theta is equal to the inverse tangent of 3. When I enter that, I'm going to get a value for theta. That is 71.565 degrees. The thing is, tangent is positive in 2 quadrants. So I have to find the location of this angle in quadrant 3. So if I think about where 71-ish degrees, it's right here. Well, in quadrant 3, I'll be looking for a reference angle that is 71 degrees, which will end up being here. So in order to find the whole angle, I just have to take the angle that I've been given and add 180 to it, which means that theta can also be equal to 251.565 degrees. For this next problem, I have secant and I have cosine. So I know some things like secant of x is really 1 over the cosine of x. And I can either divide by cosine on both sides, or I can multiply by cosine on both sides of the equation, depending on what I want to deal with. If I have cosine in the denominator, that means that I'm going to be working with inverse secant, whereas if I have cosine as a numerator, then I only have to deal with inverse cosine. So what I will do is I will multiply by the cosine of x on both sides of the equation. That leaves me with 1 is equal to 9 cosine squared of x. Then I can divide by 9 and get that 1/9 is equal to the cosine squared of x. I then take the square root of both sides, and I'm going to rewrite this as the cosine of x is equal to 1/3 or negative 1/3, because remember that if we took negative 1/3 squared, we'd get positive 1/9. So now x will be equal to the inverse cosine of 1/3 or the inverse cosine, actually I'll erase that, there's not enough space, of negative 1/3. Because this is x, I'm going to make sure that my calculator is in radians. And when I take the inverse cosine of 1/3, I get that x is equal to 1.231. If I think about this as being in radians, I can think about the fact that 1 radian is here. So 1.2 radians is probably like there-ish. Well, again, remember that cosine is positive in 2 places. So I need a reference angle that's 1.2 radians here. So to get that, I will take 2 pi minus the value that I was given to find out that the other value is 5.052. I'm not done though, because I still have to take the inverse cosine of negative 1/3. When I put that into my calculator, I get that x is equal to 1.911. Again, that's in radians. Cosine is going to be negative in these two. So 1.911 has to be here, which means that I'm looking here. In order to get this value, so what I'm going to do is take 2 pi minus this. There it is. And I will get 4.373. Next example, I have cosine squared of theta is equal to 3 sine squared of theta. That theta tells me I need to be in degree mode. I will divide by sine squared of theta on both sides. So I get cosine squared of theta divided by the sine squared of theta is equal to 3. And I know that that's the cotangent of squared of theta is equal to 3. When I take the square root, I know that the cotangent of theta is equal to square root of 3, or it could be equal to the negative square root of 3. For this problem, we can actually use our unit circle, because remember that cotangent is just x over y. So I can look here and see if I take x over y, I will get square root of 3. And I can also have square root of 3 here. I can have negative square root of 3 here, and I can have negative square root of 3 here. Remember how I said inverse cotangent, you're only allowed to work in this half? That rule has now gone out the window, and the reason that has gone out the window is because I'm actually undoing an equation. And because I'm undoing that equation, I can use any of these values. So, to have the cotangent of theta equal to square root of 3, theta will be equal to 30 degrees. Theta will be equal to 210 degrees. To have the cotangent of theta equal to negative square root of 3, theta will be equal to 150 degrees, and it will be equal to 330 degrees. There was no calculator steps involved in this one. This next problem is a little bit trickier, not because of the trig, but because of the algebra. This is one where you would have to factor. So the first thing that we'll do is we'll subtract cosine of theta from both sides. And what I will do on a problem like this is I will let A equal the cosine of theta, because now I've got 6a squared minus a minus 1 equals 0. And that makes it a little bit simpler for me to factor. This is probably much more difficult than any factoring problems that I will give you on a test. But remember, to factor, you're just reverse foiling. So to multiply together to get 6, you would have 3a times 2a, so that would be your 6a squared. You would have a plus and a minus, and then to multiply together to get -1, you would have +1 and -1. And you can always check your answer. 3a times 2a, that's 6a squared. This would be minus 3a plus 2a, so that gives you -a, and then -1. So that all works out. Now that I've done this, I can plug my cosine back in, and I would have 3 cosine of theta plus 1 and 2 cosine of theta minus 1 is equal to 0. And the rule about multiplying is if you're multiplying two numbers and one of your numbers is 0, your whole product is 0. So 3 cosine of theta plus 1 is 0, or 2 cosine of theta minus 1 is 0. So now I just solve this just like I solved the last one. I would have 3 cosine of theta is equal to -1. I would have cosine of theta is equal to -1/3. On the other side of this, we have 2 cosine of theta equals 1, so that cosine of theta is equal to 1/2. So in my calculator, I will put the inverse cosine of -1/3 into the calculator, and I will find that theta is equal to 109, that's a 09.471 degrees, and I know it's degrees because there's theta. And I also need to take 360 minus this number, which will give me 250.529. On the other side of that, I have the inverse cosine of 1/2 is equal to theta. And for that one, actually, I can look right on my unit circle because that exists. So where's the x value equal to 1/2? Well, right there at 60 degrees. So theta is equal to 60 degrees. And that also exists here at 300 degrees. All right, here we have one last problem, and with this one, the trig function is actually the first thing that we need to manage. So the first thing that I have to do is I have to get rid of this trig. So I take the inverse sine of 1/2, and I don't need a calculator for that. I see that I've got 30 degrees here, 150 degrees here. So I know that theta plus 40 has to equal either 30 degrees or it has to equal 150. So when I solve for theta, I get that theta is equal to -10 degrees and that theta is equal to 110 degrees. Well, remember with these problems, we are looking for solutions between 0 and 360. And -10 degrees is not between 0 and 360. However, -10 degrees happens to be right there. So if I'm going backwards 10 degrees, that means really I'm going 350 degrees. So the solution to this problem is that theta is either 350 degrees or 110 degrees.